Right, guys, so we are starting with quadratic patterns. There's actually nothing new with quadratic patterns in grade 12. The only sort of new extension stuff that we do is based on arithmetic sequences, and then we do geometric sequences in grade 12. So those are the only two new concepts when it comes to like number patterns. And we build on those as we start to do some formulas, sum to infinity, sigma notation. Just ignore my cat, I do apologize. It's very polite. But in terms of quadratic patterns, what you know from grade 11 is it. That's all you need to know. There's nothing new that we introduce in grade 12 when it comes to quadratic. So this is hopefully a bit of revision. But again, like if you're feeling confused, just say so and we can sort it out. Okay, so can one of you, and again, unmute, raise your hand, do what you want to do. Can one of you or either of you tell me something that is unique to quadratic patterns or something that we know defines quadratic patterns? Like how can we identify that a pattern is quadratic?
It has two differences.
Okay, awesome. So quadratic number patterns have two differences. Is there anything special about any of those differences?
The second difference is constant.
Nice. Okay. So there's two differences, and then really importantly, our second difference is constant. Okay, so that's sort of like the defining feature of a quadratic number pattern. Our quadratic number patterns, as you can see here, or when we give a rule, is defined by having a squared in it. So whenever you see like n squared or 3n squared or minus 2n squared or whatever in terms of a number pattern, you know it's going to be quadratic. Another really important thing to know about quadratic number patterns, and hopefully we'll get to an example later, is the fact that your first differences form a linear pattern. Okay, this is a question we like to ask a lot. And again, hopefully we'll get to one, but if not, we will at some point. So two important things. The most important one is knowing that your quadratic number patterns have a constant second difference. The next most important thing is the fact that your first differences form a linear pattern. And we'll see that in a second. Okay, so what is really important to know is what the general formula of your quadratic number pattern is, and it's that Tn is equal to an squared plus bn plus c. That comes from, I don't know if you recognize this, comes from a quadratic equation. So we know in algebra, we've got ax squared plus bx plus c. That's where it comes from. It's the same relationship. We're just not talking about it in the context of a number pattern. Okay, so quadratic, it's nothing new. We've done quadratic equations. We've done these patterns in grade 11. And so it's something that we're comfortable with. And if not, again, we'll practice it. We'll do more algebra and we'll get it right. Okay, so if we have a look at this first example, and guys, just remember, take screenshots as we go along. If I move too fast and you need a screenshot, just let me know and I can go back to where we need to be. But yeah, just take things down as we go along so that you have it. Okay, so this first example, we've got the number pattern 4, 7, 14, 25. So just before we even delve into the questions, what I would always do is make sure that I know what type of number pattern it is. English. Don't worry. It is being recorded, so you'll be able to get that recording, but yeah, just try your best. Like I also understand that the load shedding schedule's been a bit wild today, so I get it. So the first thing you need to do is you need to identify what type of number pattern it is, because that's going to tell you what formulas you need to use, what rules you need to use, etc., etc. Now, most of the time in a test or an exam, we will say to you, consider the following quadratic pattern or consider the following linear or arithmetic pattern. We generally don't leave you to guess what it is or try and figure out what it is. So generally we do tell you, but if we don't, we need to figure it out. So this now goes back to the first differences and the second differences that Ntwariso mentioned earlier. Okay, so what I always like to do, I do this with any number pattern that I'm working with. So I just work out what my differences is. So 4 to 7, I'm adding 3. 7 to 14, I'm adding 7. 14 to 25, I am adding 11. Because automatically that's going to help me in the next question where I have to determine the nth term. But it just gives me a little bit more information about what's happening in this pattern. And then, as we were told, we know that our second difference is constant. It would also help if I wrote the right number down. So our second difference here, we're adding 4 each time. So that's the first thing I do with any number pattern, whether it's linear, quadratic, geometric. I just figure out what's going on. What am I adding? What am I subtracting? Is there a ratio? Is it constant first differences, constant second differences? Because all of this information helps me to answer the questions later on. So the first question is asking me determine the nth term of the sequence. So guys, what does that actually mean? If I say determine the nth term, what am I looking for? And again, feel free to unmute to answer if you want, otherwise we can use the chat. So what does it mean when I want the nth term? Nice. Okay, so exactly, it's the general formula. So another way of phrasing this question would be looking for your general formula. Right, so when it comes to quadratic number patterns, there are 3 steps to finding your nth term or your general formula, whatever you want to call it. In each of those 3 steps, we are able to determine A, B, and C. So if we're not too sure where the A, B, and C are coming from, the Tn equals n squared plus Bn plus C. So through those 3 steps, we're able to find A, B, and C, and so find our nth term. All right, so does anyone remember what those 3 steps are? It's 3 equations that we use.
For the second difference, it's going to be 2a is equals to 4. For
Nice.
the first difference, it's going to be 3a plus b. And then for the quadratic, it's going to be a plus b plus c.
Awesome. Okay, so those are your 3 steps that you have to use in order to find your, in order to find your general formula. So exactly as Ntwariso has said here, 2a is equal to our second difference. So if we just sort of match up what we're doing here, this very first equation that we have is going to be equal to whatever my second difference is. The next equation, the 3a plus b, is going to be equal to whatever my first difference is. So the very first difference between term 2 and term 1. And then finally, my last equation, the a plus b plus c, will be equal to the first term of the original quadratic. And that's why I always go and actually break down what the sequence is saying. Because once I know that, it's easy for me to solve my other 3 equations. Okay, so nice and easy, a is equal to 2. Once you know what a is, you're going to substitute it into the next equation. So this would be 3 times 2 plus b is equal to 3, which means 6 plus b is equal to 3. And so b is equal to -3 because we subtract 6 on both sides. And then again, same thing. We're going to take the values of a and b that we've already found. So 2 plus -3 plus c is equal to 4. And we use that to find c. So in this case, c is going to be equal to 5. And once you've got those, you just sub it back into that general formula. So d of n is equal to 2n squared minus 3n plus 5. And you've got your general formula. What I always like to do, guys, is I always just like to double check myself. Not that I don't have confidence in myself, but it's always nice to know that what you've done is correct. And it's a very easy check. So if you do want to check that what you have done here is correct, quite literally all you need to do is you need to take the terms from your pattern and substitute in. So if I want to figure out what term 1 is, I would substitute 1 in place of n. And because I know what my pattern is, I should get that my answer is equal to 4. If I get my terms that I have when I substitute in n is 1, n is 2, n is 3, etc., then I know I've got my correct formula there. Bariso, you good?
Yes, I'm good.
Cool. Alrighty. So essentially that's how you find the quadratic general formula of a sequence. And like I say, if you've got those 3 equations, you are golden. Right, so question B is asking to find the 12th term of the sequence. So can someone explain to me or walk me through how we would find the 12th term? What steps would I need to take in order to do that? Again, you can unmute yourself. Ah, nice. Go click off.
You're gonna substitute 12 by the n part.
Awesome, awesome. Okay, so guys, that's really important. If I'm giving you a position, okay, that translates to a value of n. So exactly like Clefo said, all we need, all we need to do now is substitute 12 in place of n. So Clefo, do you want to walk me through my substitution? You don't have to. I'm just asking.
It's gonna be T12 is equals to 2 times 12 to the power of 2
Nice.
minus 3 times 12 plus 5.
Perfect. Okay, so I'll give you guys a second to do that on your calculator just while I mention something else. Another part of our notation is this whole T thing. So we did learn it in grade 11, but this is essentially a notation to say the value of a term. So Tn is your term value. So in our sequence, what was it? 4, 7, 14, 25, etc., etc. If we now have in our subscript, so in that little number at the bottom, an actual number, so like Clefo said here, T12, we're saying the value of a specific term, in this case, the value of term 12. All right, so that's just like a little notation thing. It's nothing that you need to stress yourself overly about, but it is important to know because sometimes what we do is in a question, we'll use that notation. So it's really important that we do understand what the my English there, what that notation is saying to us. Okay, so guys, what did we get for the value of term 12 here?
$257.
Nice. 257. Right, so determining the value of a specific term is one of the easier questions because it is just a straight up substitution. Chuck it in, put it on your calculator, and you're done. Okay, nice. So my question C is so far away from everyone. Okay, we'll accept it. Okay, so question C is now asking us to determine the term in the sequence equal to 907. So what I'm going to do here, just to make it bigger, because otherwise my eyes are not going to feel this. Just going to write out our rule there. And so now we want to determine the term in the sequence. So which term has a value of 907? So who wants to walk me through how we would do this? And Apiwe, welcome. I do see you've joined. Welcome, welcome. Sorry, guys, my cat's just having a moment today. You can just ignore him. Okay, so how would we do question C? How would we approach this question? Click off.
In place of the Tn, you're gonna put 907.
Awesome. Okay, so guys, now I'm giving you a value of a term. And so exactly as Kaklejo said, we now replace T in with that value. So when I tell you this term does have this value, we know what T in is. All right, so we know 2n squared minus 3n plus 5 would be equal to 907. Okay, now this is what I was saying earlier. This is just a quadratic equation, okay? And what we need to remember when we're solving quadratic equations is the fact that our goal is to factorize, have one side equal to 0, and then get the answer of each of our brackets that we're working with. Now, what often happens is in sequences and series is we end up with an equation like this. Now, I have no desire to go and try and factorize 900 and something as my last term. There is no desire, but we have got a way to factorize any quadratic equation with the quadratic formula. Right, our first step, however, is to get it into standard form. What that means is make one side equal to 0. So we've got 2n squared minus 3n plus 5, and then using our inverse operations, we bring the 907 over. Essentially what you're doing is you're subtracting 907 on both sides. And so that then gives us a quadratic equation of 2n squared minus 3n minus 902. Okay. Once it's in standard form, if you feel strongly that you can factorize this, you're much better than me, because I don't think I would attempt to factorize this in my head. You are welcome to. But remember, you've got the quadratic formula that you can use, and there's no reason why you shouldn't. So our quadratic formula is minus b plus or minus the square root of b squared minus 4ac all over 2a. So you can just substitute into that formula and you can get your values of n. So I'm going to give you guys a minute or so to do that substitution and tell me what values of n that you get. Just remember, guys, when you do use a quadratic formula, you have to show your substitution. Okay, so you don't have to write the formula down, so you don't have to write what I've written down in green, but you do have to show the substitution. Okay, your marker needs to see that you've substituted into the formula. If you're going to choose to factorize, you have to show the two brackets equal to 0 before you get your values of n. Okay, but I'll give you a second or two, and then we'll see what answers of n that we got. Anyone want to give me a value for n? Or values for n rather, we do get 2. Does anyone got a value of n for me?
N is equals to 2, or n is equals to negative 41 over 2. But when you put 2 into when you substitute 2 into n, it does not give you the value 907. It gives you, instead it gives you 7. So n is not equals to 2. Therefore, n is equals to negative 41 over 2.
Okay, so I like that you are substituting into check, and I like that you are eliminating one of your answers. So Marisa, can you just double check though that your substitution is correct? Because I got n is equal to 22, not 2. So I got the negative 41 over 2, but I got n equals 22 or n equals negative 41 over 2. Does everyone agree with that, or do we disagree? So my answer.
I forgot the 2.
Okay, no, that's cool. That's cool. I was panicking that I'd done something stupid because it happens to me all the time. So that's perfect. But do you agree it's 22?
Yes, I agree.
Okay, awesome. Now, guys, I want to go back to what Ntwariso did there. You don't necessarily have to substitute back in. Obviously, you can. That's fine. But what you need to take note of is what values of n n can be. Okay, so what's really, really important is n can only be natural numbers. And the reason for this is because if you think of a number pattern, you always start with term 1, term 2, term 3, term 4, term 5. Those are our natural numbers. Natural numbers are 1, 2, 3, 4, 5, so on, so on, so on. So when we are looking at solutions like this and we're getting two different solutions, we can always disregard any negatives and we can always disregard any fractions. So exactly like we were saying earlier, check your answer. If it's a fraction or if it's a negative, you eliminate it. Now, in this case, our fraction is negative, so we're like doubly eliminating that one. But n can only be a natural number. And that's because of just how a pattern works. It's the first, the second, the third, the fourth, the fifth. We're not going to talk about the negative third position. That doesn't exist in a number pattern. It is the first position, the second, the third, etc., etc. Right, so really importantly, n can only be a natural number. And so what that means is you do want to double check your answers to make sure you've got the right one. Now, I'm hoping we're out of this habit, but often in like primary school, I know it especially, we would then try and summarize and say, therefore the 22nd term is equal to 907. Don't do that. Don't waste your time. You stopping at n equals 22 is perfect. There is no need to give me a statement ending yourself off. Obviously, if you want to, there's nothing wrong with that. But at this level, there's no need for that. I know some people do like to do it, which is why I'm bringing it up. If you want to, that's cool, but don't waste your time. N equals 22, perfect. We know that the 22nd term will have the value of 907. Oh my gosh, I've got a frog. Alrighty, so what I'll do is I'll just make that a touch smaller. I really gave myself a lot of space here for this question. I was clearly enthusiastic about everything I was going to write. I will just do that. And then if you guys want to take a screenshot of that, you can do so. Otherwise, we can move to an example that you're going to try. Excuse me. I'm going to drink some water now and get rid of this frog. Does anyone have any questions about this first example? Cool, guys. And like I say, like I think, and I'm making an assumption, you can tell me if I'm wrong. I think we're comfortable with quadratics. We've been doing them. Some of you might have even started them in grade 10. You've been doing them now since grade 11. So they're not new. So hopefully we're good, but obviously if you're not good, you just shout. Right, so guys, there are two questions that I've put here that you can try. And sort of what I've done is, depending on how you're feeling about the quadratic number pattern situation in life, you can decide which one you want to do. So I've got an easier one if you're not feeling super comfortable about quadratics, and I've got a slightly harder one if you're feeling like, cool, quadratics, I understand this, let's do it. You don't have to do both. What I'll do is when we do the answers, you can just take a screenshot of both. So if you did the easy one, you can practice the medium one. If you did the medium one, you can practice the easy one in your own time. But pick one to do, and I'm going to give you 5 minutes to do it. If you've got questions, just unmute yourself, ask the question. If you're not too sure about where to go, you can pop it in the chat. Again, unmute yourself. But let's try one of them. You don't have to do both, just pick one. Either the easy or the medium, and then let's see what we get. If you guys are done, just so that I can see if I need to wait the whole 5 minutes, you can pop a little smiley face thumbs up in the chat, just so that I know you're done. Obviously, no rush, still got time, but I don't want to sit in awkwardly silence if we don't need to. Okay, guys, what do you think? Are we ready to look at some answers? Do you need another minute or two? Just let me know. Grade 12, do you need some more time or should I put up the answers? You can just give me a thumbs up or a thumbs down. Yes, no. Okay, thanks, Nicole. I'm gonna go with yes. Obviously, guys, like if you're not finished, don't stress, take a screenshot. And then the words will eventually come out my mouth because geez. Alrighty, so let's just get rid of these. If we have a look at the easy one first. So again, like I say, always start with what's going on in your pattern. Work out what your first differences are, your second differences are, just makes your life easier. And then it's exactly the same as what we did earlier. Find A, find B, find C. And then substitute that 5, 5, 7 in so that you can figure out which term it is. All right, so nothing too tricky there. I've also just realized that I did not do on half the question in question A said. So question A said find the general term and then determine the 20th term. This is why it's important to read the questions. So if you want the 20th term, T20, whoopsie daisies, is equal to 3 times 20 squared plus 4 times 20 minus 2. And then I have 3 calculators in my bag for this exact reason when I panic. Oops. So term 20 is equal to 1,278. Did you agree with that? Those of you that did the easy one. Yeah, I'm gonna go with a yes. Right, if you did the medium one, thanks, Kakako. If you did the medium one, so again, don't read my own question, don't do the full question. Same thing, set up your first differences, your second differences. This one was a slightly harder one because of the fact that your second difference was negative. It doesn't change what you do. It just, you have to then bear that in mind as you're starting to do your calculations, because we know that whenever we have negatives, there might be a sign change. We just need to be careful. Right, so again, I asked for the 25th term. So T20 is equal to minus 20 squared minus 3 times 20. And this is exactly what I'm saying, guys. When you substitute in, always put brackets around your value, because according to this first term, we would first have to square the 20, which was 400, 400. And then we would have to apply the negative. So it's actually negative 400. If we mess up our negative, it's going to give us a weird answer, because we know that when we square a negative, we get a positive. So the 25th term here, it's clearly a Monday of Mondays. There we go. 25th term here is equal to minus 700. Right, and then question B, again, you were given a value, you sub it in, use a quadratic. Again, if you can factorize 810, go you. I don't think I could do that in my head straight off, just like looking at it. That's why we have the quadratic formula, but otherwise use it, find your values, and remember, we never want to include, or we can immediately ignore anything with a negative or a fraction or a decimal. All right, nice. How did we find those two? I'm just going to do that so you guys can screenshot. Were they fine? Did anyone do the medium one? Did we all do the easier one? Easy one. Nice, Pure. Sometimes it's good to actually just start with the easy stuff, get back into your groove. You've got the screenshot of the second one. You can do it when you have time, but sometimes it is just better to start off slow rather than, what's the phrase? Don't run before you can walk. Boriso, nice. Well done. The second one, I don't want to say is very, very challenging, but it's the negatives that sometimes throw us. So many kids make mistakes and lose marks just because of a sign. So when we start practicing those, it helps us. Okay, guys, I think we got time for another one. So let's have a look and see. Actually, before I decide which one we're going to do, are we feeling good about quadratics, or are we feeling like we maybe need one that isn't a huge step forward? If we're feeling good, I'm going to do one slightly more challenging. If we're not feeling so good, then we'll keep it easy. Feeling good? Nice. Opiwe, Toriso, how are we feeling? Good? Okay, awesome, guys. That's what I like to hear. So we're going to go and do one that I don't want to say is hard, because it's not hard, but it's one where we do just need to think about what makes a pattern quadratic. Okay, and Toriso told us this earlier. It is constant second difference. And then we added to the fact that the first differences make a linear pattern. Excuse me. So this is the type of question we like to ask with quadratics, because you should know quadratics from grade 11. And so it's often the question that we make a little bit harder, or like the problem solving complex question. And then we introduce x's, like this example here. So we've been given the quadratic pattern, -2, -1, x, -5. So really importantly, they've told us it's quadratic. And because they've told us it's quadratic, we can immediately assume that we will have a constant second difference. Okay, so if I tell you something is true, you can assume everything. So for example, if I said this is a parallelogram, you can immediately assume everything about the parallelogram is true. Opposite sides parallel, opposite sides equal, diagonals bisect, etc., etc. All right, so again, what we're going to do is we're going to set up what is happening in this pattern. So I know to get a first difference, let's maybe do this, if I want my first difference, I would have to say term 2 minus term 1. So for the first one, it would be term 2, which is -1, minus -2. And what that gives me is that I'm actually adding 1 here. Now, I know you guys know this, and I know you guys can just do this in your head, but it's really important to know how we are working out these differences when there's an x. Because now when I want my next difference, this would be term 3 minus term 2, which is x minus -1, which is actually x plus 1. And the same thing for the next step. If I now want my next difference, it's going to be, let's go here, term 4 minus term 3, which is then -5 minus x. And so this difference is -5 minus x. So, excuse me, it's really important to know how to actually calculate those differences, because like I say, in questions like this, where you have to work out x, you're going to rely on those differences. All right, so we've got our first differences. It's all in terms of x, but what's really important is that we do work out our second differences. And the reason it's so important that we do go find our second differences is because of what we said here. The fact that your second difference is constant. We can use that fact to our advantage. So to work out the second differences, it's the same procedure. So our second difference here would be x plus 1 minus 1. If you want to put in the brackets, that's fine. Let's actually do that a bit neater. And then our second difference here would be -5 minus x plus 1. And what I want you to take note of here is I've put that second term in brackets, because again, like I was saying earlier, when we have negatives, we need to remember that we're going to have to distribute, and those negatives affect our values. Now that we have sort of our information about our sequence, we can start looking at the questions. Before I do that, is everyone fine with what I've done there with the first and second differences? It's a lot of algebra work, so I just want to make sure we're all good. And again, just give me a thumbs up. Marisa, up here, are we fine with the algebra that I've done there? And again, guys, I'm just checking because it's the simple things that often trip us up. So it's the algebra, it's the negatives. Those are the things that often trip us up because we're so focused on getting the complex stuff right. Okay, awesome. Toriso, if you're not okay, just let me know. Okay, there we go. Cool. Okay, guys, so now we know this. So what we know is that these second differences over here have to be constant. They have to be the same value. And because we know that, what we can do is we can set up an equation. We know that whatever x plus 1 minus 1 is, has to be exactly the same as whatever -5 minus x plus 1 is. It is a constant second difference. They have to be the same. And this is why I was saying earlier, it's so important to know the characteristics of your patterns or your sequences that you're working with because of questions like this. If we didn't know about the constant second difference, we wouldn't have any idea what to do. But because we do, we've got this equation we can now solve. Okay, so what I want you guys to do, I'm going to give you like a minute or two. I want you to solve for x here. So tell me what is the value of x. I've set up the equation for you. I want you to now go and finish it off and solve for x. Right, and again, guys, like I did here, remember your brackets around what you're subtracting because you do need to distribute that negative. Again, it's just like one of those things that I know you know, but we forget to do when we're in a test situation, we're under pressure, we're feeling a bit anxious. So always just, if you get into the habit of putting brackets, you're good. Kakleho, close. Just double check your coefficient of x there, because the -6 definitely comes into your steps when solving, but there should be a coefficient to x there. Nice, Apiwe. Nice, Pariso. Okay, so let's double check. So on the left-hand side, we've got x plus 1 minus 1, 0. So we don't need to do anything there. And then we've got -5 minus x, distribute that negative in, minus x minus 1. Okay, so how you choose to do this and how you choose to solve an equation at this point, skip steps if you can, and if you want to, that's cool. So what I'm going to do is if I bring those two negative x's over, I've got 3x and -5 minus 1, -6. So Kakleko, that's what I was saying. -6 definitely is in our working out, but because you've got a coefficient here to x, you have to divide both sides by 3, giving you -2. Okay. Nice. All right. I'm glad it makes sense. And again, it was probably just, silly mistake. They happen to all of us. It's okay. Just remember your inverse operations. Right, so now that we've got this value of x, what I always like to do, and you don't have to, but it is useful because invariably the next question is going to ask you something based on the pattern, is I like to put it back into my pattern. So I've got -2, -1, -2, -5, and then we've got our whole pattern going on. Right, again, just see what's popping here. So this was +1, -1 to -2 is -1. -2 to -5 is -3. And then when it comes to my second differences, 1 to -1 is -2. -1 to -3 is -2. So we've got a quadratic pattern. Constant second difference, which we worked out, excuse me, and we've got our first differences forming a linear pattern. Alrighty, guys, so 2 minutes. 2 minutes, yeah, let's try. I want you guys to try and find the nth term of the sequence. Now we know what the sequence is, so we just have to apply those 3 steps in order to find A, B, and C to get what Tn is equal to. All right, so I'll give you, like I said, 2 or 3 minutes. Let's work out what Tn is equal to. Kaklejo, does it make sense now? Are we all good? And everyone else as well. Piwe, Floriso, are we all good? Amazing. Awesome. Okay, guys, did we all get minus n squared plus 4n minus 5? Nice. Okay, so those three equations like I have there, so a was -1 when you went and substituted in math. We got b is 4, and then c again when we substituted in, we got that c is equal to -5. So if you've got those three equations, those three steps, you can find a quadratic pattern quite easily. Okay, grade 12s, you were amazing. I know it was a very small class and hopefully it will get bigger, but I really appreciate you being here. It's awesome, and I hope that you will continue